Hi, so today I will be talking about mathematics behind soccer. Soccer is a sport that uses a variety of mathematical and scientific principles. These principles include geometry, calculus, physics, and probability. Ever since I was young, I enjoyed watching soccer games along with my family. Once the soccer game started, we would all stop what we were doing and watch the game. Soccer would always grab my attention. Every time I would watch a game, I was amazed by it, of how strategic every game was played. Now, as a high school student, I have played on the Arvin High girls soccer team. During soccer games, especially during free kicks, mathematics is taking place. My question, therefore, is how is a soccer player able to bend or curve the ball over a wall during a free kick? An example would be the match between Brazil and France in 1997 when a young player named Roberto Carlos made soccer's most interesting phenomenon through a soccer kick. As you can see, he was able to bend the ball at an angle that the ball circumvented and avoided the four-man wall that was blocking him from making a straight shot. In order to bend the ball over a defensive wall, Roberto Carlos had to strike the ball in exactly the right place by hitting the ball off the center of mass, hitting it almost to the side of the ball, and using the inside of the foot to wrap around the ball to generate spin. Once spin is generated, it creates a difference in pressure between the inside of the ball and the outside of the ball, tending to push the ball towards the direction of the pressure, allowing the ball to curve over the wall. The keeper won't see the ball until the last minute. The formula D equals pi times r cubed times p times w over Vm, where D is the distance the ball bends, r is the ball's radius, p is the density of the air, w the ball's angular velocity, v the ball's velocity through the air, and m the mass of the ball, demonstrates the distance a ball bends as a result of what is known as a Magnus effect. The Magnus effect helps explain how Roberto Carlos was able to curve the ball. It states that the spinning ball grabs the air and pulls it along the larger path, and on one side of the object, the whirlpool motion will be only slightly affected and the velocity will be slower because of the shorter path it will take. The motion of the whirlpool on the other side, however, will be greatly affected, following a much longer path and have a greater velocity, creating a force perpendicular to the line of motion. The Magnus effect takes into account the viscosity of the air as well. The formula D equals pi r cubed times p times w over Vm, I will find the distance the ball bended for Roberto Carlos and his free kick. In the case of Roberto Carlos, in the match between Brazil and France, he was standing 35 meters from the goal when kicking an average soccer ball, traveling at a velocity of 35 meters per second and had an angular velocity of 10 revolutions per second. Now I will substitute this information onto the formula. I will be finding D, the distance the ball bends. I will have to find the next variables, which is r, that is the ball's radius, w, the ball's angular velocity. P, the density of the air. V, the ball's velocity. Through the air. And M, the mass of the soccer ball. In order to find R, or the ball's radius, I know that an average soccer ball has a circumference of 27 inches. To find the radius, I will use the equation R equals C2 over 2 pi, where R is the radius and C is the circumference. I know that the circumference of an average soccer ball is 27 inches. So I will therefore substitute this into C and get R equals 27 over 2 pi, which is about 4.3 inches, which is our R. To find W, or the ball's angular velocity, the information is already given, and I know that the angular velocity is 10 revolutions per second. To find P, or the density of the air, I know that the game took place at Matma Stadium, Gerland, in Lyon, France, in the Rhone-Alpes mountain range. The density of the air depends on altitude and temperature of location. Therefore, I know that the density of the air of the location of the game is 1.25 kilograms per meter. To find V, or the ball's velocity through the air, the information is already given, and I know that the velocity through the air is 35 meters per second. I know that the mass of an average soccer ball is 16 ounces, or 454 grams. I will now substitute the given information onto the formula in order to find D, or the distance the ball bends. So, D equals pi R, which will be 4.3 cubed, times P, which is 1.25, times W, which is 10, over V, which is 35, times M, which is 16. When simplified, I will get 3 3,122.23 over 560. And simplified further, it will be 5.58, which is about 6 feet. Therefore, our D, or the distance the ball bends, in the case of Roberto Carlos, would be the ball would bend around 6 feet towards the goal. As the ball spins, friction between the ball and air causes the air to react to the direction of spin of the ball, as explained here.